Let's take our same circle, right, Brian? The same circle. Brian. That is the radius. Good observation. That's the radius. This angle is called
angle.
Close.
Angle and arc.
The beta.
Theta. 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 Theta.
How do you say it?
Theta. Theta. All right, I'm gonna throw one more variable in here. Y'all ready? This length across, which is just a portion of the circumference, right? So this portion is what I'm referring to whenever I say arc length, and we usually denote that with an S. Dang, we were 2 days shy. Wait till you see how easy it is too, and you'll go, oh my gosh.
What did you say with S?
S is arc length. That represents arc length. Here's the caveat. Your theta must be in radians. It cannot be done in degrees. You need to switch it over. To find S, you take the radius and times theta. That's it. But if your theta is not in radians, bruh. Radius times theta gives you that arc length. We'll start out easy and then we'll what? Yeah. Like you don't have to draw it, but if I say draw an angle that's a central angle, all you need to do, if it's more than 360 or it's negative, keep adding or subtracting 360 to it until you get to one that's between 0 and 360 or 0 and 2 pi. Find the coterminal angles so that it's easier to find. That's all it's doing. It's just because there are an infinite number of coterminal angles. So if I'm at, say, 45 degrees, I could call that 45, but I could also call it, if I loop around another 360 degrees, what is that? 405, right? Or I could call it negative, what's 360 minus 45? Minus 325. Or I could call it, I could add in other words, it's an infinite loop of numbers that I could keep going around until I get there, back to the same spot. So if I was given this, and I was asked to graph it, I would say, okay, that's bigger than 360, so let me find a coterminal angle for that. Coterminal angle would be 45. I can graph 45. Does that make more sense?
That has nothing to do with
No, she just asked a question about what we're doing yesterday. And so I think what you're talking about, Christina, is whenever we went, okay, 45, loop around again to get back here kind of thing. Is that what you meant? We're fixing to do a lot with circles. Find the arc length. You have it. Thank you, Christina. Thank you. Thank you. How do I know, first of all, before we do this one, how do I know that it's in radians? One, there's a pi that clues me in, but it doesn't have to have, there's no degree sign, so I know it's in right. There's no degree sign, so I know that it's going to be in radians. So this is an easy plug and chug kind of thing. R times theta 5 pi over 6. 5 pi over 2, sorry. Yes, it is.
7.852981. Well, you don't put pi in there.
What is the house I do it though?
You multiply 3 times pi, 15 pi, and then simplify. You don't even multiply that.
Oh, divide by 3.
Why are we dividing by 3?
Because you get 15 over 6, they have a common number of 3. 15 divided by 3 is 5. 6 divided by 3 is 6.
Y'all don't know those little tricks? Sorry.
I'm not really good.
So we're gonna make 15
Over 6 and then simplify. Yeah. I just simplify as it's at, so I don't have so much work to do. That's okay. You don't have to. Well, 3 divided by 6 simplifies as 1 over 2. So, all right, guys, let me reel you back in so we can get done so I can grade your test. I know you want your test graded.
Oh, my test grade, please, let me quiet.
All right, 5 over 2 next. But now listen, this is the most acceptable way to put your answer. It's an exact form, the pi stays in it. If they ask you for an approximation, that's when you plug it in your calculator and give them a decimal back. This is the exact answer. You want to leave it like that. That's the most acceptable way to give your answer. 15 over 6. Right. No, 3 over 1, so it's top from top, bottom from bottom. I'm going to put a unit here because we need to start getting used to units.
Oh.
8.4 meters. But you're finding arc length, so your unit of your answer is still going to be meters as well. Uh-oh. What's the problem?
You just have to put it right in.
You have to multiply by 180 over pi, or pi over 180.
Which one?
You divide.
Pi over 180. So I'm going to do 15 times pi over, here's my little trick again. Watch if you don't know little fraction tricks. What can I divide both 15 and 180 by? I know I can do 5, and that would give me 3 and, you can do 15? Let me show you how I would do it if I didn't have a calculator. I would say 5 goes into both, 5 goes into that, 3, 6, and then I'd go up. Now I can divide them again, 3, 12 down here, so I'd get pi over 12. No, that's fine. But that's not the answer because I was asked for the arc length there, or the, let me see how, the intercepted arc. Okay, which means just intercepted by that central angle that we've got on there, our theta. So here I've got pi over 12 times 8.4, or 8.4 pi. Can you? What's some question? That's right, because this would be 84 over 120. 1 over, it'd be pi over 7. Right? 12, oh, 7 over 10. Yeah, you're right. Oh, gracious. I don't know. We struggle with fractions, don't we?
I'm just not good at math.
You could, but you technically don't want any decimals in a fraction. That's not really proper to have decimals within a fraction. So I multiplied both by 10 to get rid of the decimal, or moved everything over 1, and got 84 over 120. And then divided both by 12. Okay, if you're not good with it, take out your calculator and do 8.4 divided by 12, math, enter. Oh, Joyce, good job. Meters. All right, if you can do this one, then we'll move on to area. Yes. Find theta in both radians and degrees. What?
Similarity.
Whoa.
Well, you don't bring
So
it
little
down.
traumatizing me.
Yeah, I got so scared.
Oh, God.
I know.
Yeah, what's that in?
Meters. You were good to ask that, Brian. You know, sometimes Brian be lying.
But what's really in right now? Yeah, what are the degrees or radius?
You tell me.
Meter.
You don't have to have a pi to be in radians.
I mean, I got that answer, but like,
Oh, yeah, I got that.
Yeah,
I got 5/3. I don't know what's going with 5/3.
5/3 is your radian measure because when you use this formula, you must be in radians. Just because there's no pi in it doesn't mean it's not in radians. It doesn't have to be there. It's a good clue that you're in radians if it's there. And you'll see when we get to unit circle why that is. You are, yes, you are.
What did you just do? I'm very confused.
What confused y'all?
I don't even know where to start with that problem. It's like there's no degrees or anything, so you can't convert it.
That's what you're finding is the theta. Your
Are you plugging it into the equation?
arc length is S. This is your S.
I don't like that art. You don't think that's too hard, right?
Oh, sorry.
I was really what did I plug it in?
That's just generally accepted. That's what it is.
You have 9 degrees. Thank you.
So, all right. If I want to convert to degrees, and here's a good rule of thumb, if you can't remember whether it's 180 over pi or pi over 180, whatever you want to get to needs to be in the top.
So degrees, 180 over 5.
It's like unit analysis in chemistry.
180 over 5.
No, you do not. You do not. You can just put theta equals 5/3. And then I also want to do 5/3 times. I want it to be in degrees, so I put 180 on the top. Again, 3 and 180 simplify to 60 here. So I get 300 over pi degrees. Yes, 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 yes. Oh, that's half of it. We got area.
Wait, so I think it's in my
This wasn't on your. Oh, the. Okay, this is weird because there's no pi in the radians here. That's why this one's throwing you.
You don't just want to lie.
Let's do a word problem with this.
No,
Oh, I hate words.
no.
I'm not in English right now.
Cincinnati, Ohio is directly north of Atlanta, Georgia. Did y'all know that?
Yeah.
Actually, yeah. Directly. Straight north, baby. No, I don't know. This is what the problem says. But they would lie, right?
They do.
I mean,
They lie about how many things apples have.
yeah, like they say John had 36 like cars or something.
Right.
Yeah, Like John had, ain't no way John had 36 cars.
He has 36 cars, but he only spent 12,000. How much would he spend?
Yeah, like.
Bro, $3. Yeah.
Cincinnati has a, here we go with the latitude and longitude, right? Cincinnati has a latitude of 39.1 degrees north. And Atlanta, Brian, you be lying. That's what I'm going to start saying all the time. That's what y'all said whenever you walk. Somebody said that whenever y'all walked in the door. Brian, you be lying. It kind of has a ring to it. Yeah, see, Brian, you be lying. Atlanta's 33.7 degrees north. The Earth has a radius. You know, if you travel to the middle, you know, journey to the center. Yeah. Oh, see? Okay. 3,960 miles.
I love that movie.
I just gave them a little visualization here. Y'all ready for the question? Now what do we do with this?
We take the radius.
How far apart are the two cities? Subtract what?
You're gonna get 5 point.
Wait, what are we trying to find?
What's the question?
Cincinnati's latitude is 39.1. Atlanta's latitude is 33.7. The radius of the Earth is 3,960 miles. How far apart are the two cities? 5.4 miles? That's not right. That's not right.
Should we just be like our time?
That would say that Cincinnati and Atlanta are 21,000 miles apart. 21,000 miles? The whole Earth is less than 8,000 miles wide. Oh, silly me. Okay, we'll turn into radians. What happens? Ladies, silly. We got to turn it into radians. Okay, so 39.1 times pi over 180.
Whatever you say, like, now we're gonna get this rate. I'm thinking 5.1
She's talking about the longitude.
You're going DMS. We're not going to go DMS. We're just going to stay. The only thing I'm going to have you do with DMS is converting, but past that, we won't do any. No. All right, so in radians, I got 391 pi over 1,800. I literally did this divided by this and hit math and enter. All right, let's do this one. Okay, I'll wait on you.
This dude is Christian. Why is he saying happy Ramadan, bro? Like,
What's that mean?
it's like a Muslim thing.
Oh yeah, they don't eat until like 6
Exactly. They can't eat during the day. Like, over here saying happy like Muslim Christian. He's a whole Christian, bro. And he's a homosexual. I don't understand. Like,
All right. 2 different radian degrees. Think about this. Think about what this means, and it'll make more sense to you on how to solve this, right? I hope, anyway. How far apart are the two cities? So if I go from the same starting point, we're going from the equator, right?
Yeah.
So this is the Earth. Here's my radius. If I go, and this is not going to be accurate on the Earth, but I'm just saying, let's say this is theta sub 1 and this is theta sub 2, just so you can see them differently. So here's Cincinnati. This is theta sub 1, right? And then here is theta sub 2, right? And whenever I find arc length, well, the arc length of this one is going to be here. The arc length of this one is going to be all the way around. How do I find how far apart? There you go. This distance is going to be the difference of the two. I don't think that's going to give you the right 5.4 pi.
It would be a decimal point over pi, like decimal point pi over a number.
Okay, let's think about this on the picture. If you took this whole minus this, it would give you the.
That way we don't have to multiply.
What are your radians? 3 pi over 10 times pi times the radius, which is 3960. You're off by. It's off by 10. Oh, it's 3 pi over 100. Yep. So yes, you can do that. You can do that. My bad, Lainey. That's on me. My way's not wrong. Okay, I haven't done it yet. All right. I'm going to do the arc length of each one, and then I'm going to subtract. And then I'll show you what Lainey did. She did about half the work that I did and still got to the same thing. Yes. Not the radius, but the arc length. So for this one, I'm going to do, Brian, I know you be lying. Radius times theta, 391 pi over 1800. I'm not subtracting yet. Right now, that's my whole length. I'm going to find the other length.
So if we did Lainey's way, we would have to do this part.
Correct.
Lainey's way is a lot faster. I think we should
Subtract the two thetas and convert it over. And do the arc length there. Either one's fine. The answer is approximately 373.2 miles, which is a whole lot better than Stella's 20-something thousand miles. All right, this one, if I get a decimal here, let's get it over in a decimal. Times pi. I'm just plugging all this in straight in the calculator, y'all. Times 3960. Oh, you can.
I know you can, but like everyone's like, no, you don't do that.
When it's just asking for the theta, leave the pi in there. But if you're trying to find other stuff,
Looking at it, I could not tell you how to solve that.
no, and I wouldn't expect you to.
Yeah, we need to look at that.
You do have pi in your calculator. What? When I subtracted these, I did get this. Okay.
Me either. I got 4.
Okay, I think y'all are putting it in wrong. Here's the way I do it to make sure. I do 391 divided by 1800 and hit enter. And then I hit times pi. And then I times 3960.
So why would you not do the
Why
pi
wouldn't
times
you
3960 times 391 divided by?
Oh, no, I got that. I got that.
Pi.
You can.
Okay.
But you still get
3960 parentheses 391 divided by 1800 close parentheses second pi. I got 2702.398.
I was just multiplying. 3960 times 391 and then. Y'all remember what
You get it, Avery?
No, I need to find it.
Yes. Now, if you did it the other way, so if you subtracted these first, you got what? 5.4? If I change that to radians, so multiply by pi over 180, and now I multiply that by the radius, showing you that it works both ways. Okay, this one was a cluster. We're definitely doing another one of these.
So what you got? I got 269.5.
What?
3960 times 39 times 5 divided by 180. Oh wait, I didn't put 150.
391, not 39 pi.
Oh, are you sure 391?
Yeah. Oh, it is 39.1. Yeah, 39.1. Sorry.
Or are you doing 39 times?
No, it's 391 over.
You just accidentally.
Yeah. All right, y'all ready for this one? Put your thinking caps on. That was the second way to do it. Subtract them. Subtract the thetas to start with, so that you have a smaller theta to work with. Then you just find the sector area of that. All right. Y'all ready for this? A merry-go-round. I'm not gonna do it. I have a little merry-go-round. No, like a merry.
Y'all should be very impressed to have a prop for my lesson today. It's a unit circle. Oh, whoever did that has blue next to that. Ross and Oxford. Okay, I don't know. That's not ostrich. You can't just call it ostrich an emu if you want to. She said I call it an emu. Okay.
A merry-go-round rotates 2,808 degrees per ride. Wait, how does that happen? It loops around that many times, right? Until it hits there. All right. How far would a rider seated 8 feet from the center of the merry-go-round? The radius. So, okay. From the center. From the center, you sit 8 feet away from that center pole right there.
Okay, so that's the R value.
That's your R value. How far have you traveled?
8 feet.
If you rode one time. One ride takes you 2,808 degrees. How many feet did you travel over the course of one ride? So how many feet?
You dig a 6-foot hole. About like
I'm so glad that is that 2808? Is that our little theta?
Yes.
Oh, so for wait.
Mm. Where'd I get that?
Oh, I see. It's 50. That's what the giant amount.
I got them radians.
Wait, how did she come over? She did a titration.
Stop. Bro, oh my god. Oh, what I got?
Let me take it a step further. One step. No. Okay, how did I get 178? I converted my degrees to radians.
Divide 2808 by 180 and then hit math and
I was trying to get your guys focused on the math.
she can't do fractions.
Wait, no, is there another? X 950. Yes.
It's on there somewhere.
Let me see.
I got that.
Tell me this. Where, actually, not where. Name me a coterminal angle that sits on the circle. Coterminal to 2808.
Can I
Wait. Mark, set, go.
Wait, what did you say?
Name me a coterminal.
2448. 2448.
No. One. I want it on between 0 and 360.
288.
Negative 72.
Wait, you said
288. 288.
I said 288, bro.
I'm sorry.
I said 288.
288. Find me a one that is coterminal between 360.
Alright.
Don't you just make this?
Are y'all ready to do area?
Hooray! It's a good night to be a Cameron Wood audience.
Think about a piece of pizza. Okay, stop, Logan. All right. The area of a sector. Okay. Here's what I'm thinking about. Same central angle. Okay.
That right there.
I'm talking about this area.
It's literally like
Encouraging that behavior.
beating on you laughing.
He is like a middle schooler.
Hey, hey.
Oh, Christian was laughing too. It's not.
All right.
Go.
Again, here's the thing. Theta must be in radians. Go sit down, Logan. Don't mess with it.
We're like about 1/4 through.
This is the last thing. Yeah.
Oh, I thought we were halfway done whenever we just literally translated it the other day.
Oh, no. For this lesson. Logan, go sit down. I need to finish this.
Yo, I just.
Logan, I'm going to kick you out if you don't sit down and be quiet.
I can't sit.
All right. Probably going to be given in degrees. You're probably going to have to convert. It's all good. We're going to get it in radians, and then the formula. I'm glad I didn't try to derive it like I told you. 1/2 theta times r squared.
Theta is the
Central angle.
circumference.
Oh, guys.
Okay. Now, I don't have to be in standard position to do this. I can be anywhere in the circle as long as I have that theta value and the radius. I can find the area of the region. I'm going to do just one, and then I'm going to do a word problem with you that really brings me to calculus. Like, it gives me calculus vibes, but I love it.
Oh no. Mr. McGee, is this how small our free class? Also, like,
Find the area of the shaded sector.
y'all have to take notes in this class.
What we're doing right now.
No, I feel like you don't respond to it. So,
Mr. McGee, you have to take notes.
That was really insightful.
Oh.
Area of the shaded region. First check your theta. Check your theta. It's right. It's good.
Where is our theta? What calculator?
Wait, no, you're not squaring theta.
Figure out the 23.6. Oh, that's not what I was. No, I thought they were opposite.
I wasn't under the
I have 2, 6, 4, 5, 5,
How
5,
hard
6,
was it?
5. I thought it was 2. No, I do that.
No, ours is radiant.
It's not breaking in. I thought R was breaking in. And I was like, oh, hi. I was right up there. We'll figure out this. Wait.
Wait, I think I got 1,000.
Are y'all in disagreement?
I don't know. Yeah.
Okay, on my calculator, I would do 23.6 squared, and I got 556.96. And to that, I'm going to multiply by 19 pi. And I hit enter. 33245.07. I leave that in my calculator, and I hit divided by 24.
You lost me when you put 19.5.
1,385.2. And because I'm talking about area, it's square meters. You can put it together though, it doesn't matter. You can literally hit 19 and then hit the pi button. Because it's r squared, it's... You can put this in all at the same time if you want. Let me show you.
Oh, I see the issue actually. I think.
Equals 1,385.213, right?
1/2, any fraction goes in parentheses, right? Times, and then I have 19 pi over, what's it over? 12 times 23.6 squared.
I could have just done that. I'm trying to pi over 2. Oh my god. That's fine.
So, as long as we know the formula, we got it.
Let's see if you do. Let's do this one application problem and I will shut up and let you do your work. Are y'all ready? The windshield wiper in your car. The windshield wiper in your mama's car. The windshield wiper arm to the left is 36 inches long. So I'm looking out of my window of my car, pretend like it's a semicircle because these are circles we're talking about. The windshield wiper is, what did I say? 32 inches long. It doesn't matter. It doesn't matter. The wiper sweeps through an angle 125 degrees. So my wiper's, okay, this is my windshield wiper. Through an angle, find the area swept by the blade. Oh, but it says, it gives us a diagram. I forgot the diagram. Hold on. No, it doesn't. It's not like that at all. Hold on. Think about an actual...
I love how everybody's
All right, here's the diagram. Here's my windshield wiper blade, right? But it says the wiper arm itself, which I think what they're talking about is here, is 32 inches. The whole thing is 32. The whole arm is 32 inches. You know how you always have that little piece that it never hits right here?
Oh, I thought that was the entire window. That's the area that it cleans.
Yes, yes. As it goes, whoop, 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 whoop. Yeah. Find the area, and we said the wiper sweeps through an angle of 125 degrees. Okay, so my theta is 125 degrees. Find the area that it actually cleans.
What is the point? Okay, but which way did it come from?
Find the area here that it actually cleans. In other words, find that area. What is the 21?
Okay, yeah. Okay, okay.
Right.
What is that on the bottom? What else are you saying?
So this is the area from here. See, I've got this little open space because the wiper blade itself, you know, it sits on an arm. The arm's 32 inches long. The blade itself is 21 inches. Is it? It's got to go to the center. All right, let's think about what I'll do. If I use a radius of, what did you say? What did y'all say to use? 21. If I use a radius of 21, then my radius is going from here. Yeah, that's not going to work. Think about just like I was trying to do the one that Lainey did so much easier, where I did the whole thing minus the part. So why don't we find the whole area and then subtract out this little piece. Yes, yes. So what I'm going to do, I'm going to do my entire radius being 32. And then I'm going to do one that has a radius. I want just this little piece right here. Well, just that little piece is 32 minus 21, which is 11. No, 11 is going to give you this pink area. 32 is going to give you the green area. To find the blue, I'm going to have to do green minus pink. Okay. I got to take that hole out of the middle. Look at this. Let me draw it like this. This is 32. Here we go. This whole thing is 32, right? From here to here is 21, which means this is 11. Agreed? This angle's not changing. This angle is 125 regardless. So if I do the area of the hole, the entire windshield, including what it doesn't clean, which is all of this, then I can subtract out the area of the hole that's there. I use that in calculus, by the way. Hole minus hole. Okay. In all the years of calculus, no one has ever said that. It does. 985. Make sure before you start you have converted your angle to radians. So 125 is 125 pi over 180, which is approximately what? All right, so the area of the hole is 1/2 theta . Yes. 125 divided by 180. Math enter. Because of the squaring, I don't think you're going to get the same thing. Plug it in and see. That's why I was hesitant on the other one, because it never works out like that. So it was odd that it worked. But you can on the other, you just can't on this one. It has to do with the radius being squared here, is why. Right.
So 21, if you do want to start.
No.
I tried it.
All right, so this one you get about 1,117. square inches. For this one, you get about 132 square inches. And if I subtract them, you should get about 985 square inches. So your whole windshield is 1,117 square inches. And then the little hole that it's not cleaning, you're getting robbed by 132 square inches that it's not cleaning. Which means that it is cleaning 985 square inches.